That sound. All right. So we're going to go ahead and get started here. Thanks everyone for coming. My name is Matt Socio. I work at Security Operations and Services in the intrusion detection team, and we're going to go over a very basic high-level view of mod security today. So before we get going here, I know some of the faces here, but like, are you guys sysadmins? If you want to put that poll up, Jen, like how many people are like server admins? So we got server admins, programmers, developers, content managers, all of that, all of yeah. So all right, so okay, um, so basically, mod security it's called a web application firewall, but it can really be a lot more than that. It inspects HTTP requests, transactions at a very deep level, and you can get a lot of good information out of there. And as it parses all of that information, it has an ordered rule set. So for those of you that are familiar with how a firewall rule works, where first we do this, and we do this, and we do this, and then if it matches, we do the action, whether that's block, deny, allow, whatever. So mod security works much in that same vein. And as far as that rule set goes, there's an organization called OWASP, which is the Open Web Application Security Project, and they maintain a core rule set for mod security. So this is a module for Apache and IIS. We're going to focus on Apache today because that's what I know. If anybody out there is an IIS guru and has used this and wants to give this, share this information at a later date and time, contact us, let us know. We'd love to get the information out there to the community. And as a module, it's applicable at various levels in Apache, at the directory, the location, even a page level. It can also be run as a reverse proxy, where you basically put a box out on your network in front of your web servers. It'll then take all your web requests, process them, and forward the good stuff off to your web servers, which will then return content. This used to be a little more prevalent before there was an IIS module. You lose a lot of flexibility when you're in that reverse proxy mode. It's much more static. So we're not really going to get too much into that, but just so you're aware that that can be done, and there are places where it may make sense. So why are we talking about mod security? SQL injection attacks on our network are pretty rampant. We're seeing anywhere from 600 to 1,500 malicious requests a day at the border, and we have about 8,000 hosts that know how to talk HTTP. So that's a lot of surface area, and it is something that we're concerned about, because a lot of these web applications are fairly easy to exploit. And once people find a hole, the sky's the limit as far as what you can sort of figure out with that server. And just on our network, we've seen cases where we've lost data, like a lot of data. We've had websites defaced, or maybe slightly poisoned. It's been weird stuff. And then they've been involved in these SEO poisoning schemes, which is usually pharmaceutical ads that they inject stuff into the database, into the website, that causes certain Canadian pharmacies or overseas pharmacies to rise in search engine rankings. We also regularly see some cross-site scripting and cross-site referral forgery attempts, where they're basically trying to abuse what's in your cookies to get your session to do other things. And that's that can be a problem too. But we're going to focus on a SQL injection example today because it is something we are seeing a lot of, and it's what I'm familiar with. Mod security doesn't just protect against that; it really runs the gamut as far as what's out there. It is a great first line of defense for your web servers. Not only can you set it up to block that traffic, but you can really dig in with mod security and actually start to see what's going on with your web traffic. You can see files that are coming and going. You can see post requests, things like that. The Apache logs are pretty much, for those of you who look at them regularly, I mean, you're getting a timestamp, some host information as far as source IP import, source destination, some get, basic info that's good for, your web stats. But it's not necessarily as effective at being able to say what's really happening inside that HTTP transaction, and that's where mod security really shines. And like I said, it's able to detect, and if you set it to, it can block most malicious requests that we see on the network. It's not perfect. There are some places where it becomes heavy to admin, or you are able to detect it on the network and say, all right, I have mod security in play. So somebody's always going to be able to find a way around just about anything. But for our day-to-day activities, mod security is a really good defense mechanism for web servers. One of the reasons we'd like to get more people in the community aware of this and possibly using it is that it can be used as a very effective inline patch. And what that basically means is that if you have code that you know is vulnerable or has been exploited and the developer is no longer around, or the money's just not there to undertake the refactoring of the code, or it's not your code to alter. If those are the cases, then you can put mod security out there, and chances are it's going to stop any further exploit of the vulnerabilities that are there in your code. Any questions yet? Oops. So now we're going to kind of get into an example here. So we're going to talk a little bit about where mod security is configured and how this all works. So for those of you that run Apache, this should look very familiar. So what I've done is set up two directories on a virtual machine on my box here. And one of them is, so I'm using this damn vulnerable web app, DVWA. And as you can see here, I've turned it on for my protected site, and I do not have it on for just the DVWA. So Jen, if you can get me out of here, and we'll actually take a look at that. So here we have it. So I have, the unprotected DVWA. I have the protected DVWA. And to give you guys a little brief overview, this is actually a really neat package that is, if you want to learn about how wrong things can go, this is a great place to start. It's designed to run exploits against it. It's designed to give you an idea of what holes in code look like and what attacks can look like. Again, they have stuff for brute force, command execution, all this stuff down the left-hand side of the page. Again, we're going to focus on SQL injection today. So what's here is just basically a simple input form with one line, and if I punch in a number, it just returns, a first name and a surname, and I can just keep going through that. But the idea here is we want to see what can really happen here. So these are some attack. This is what a SQL injection or some types of SQL injection look like, and we're going to feed that into the unprotected DVWA and see what happens here. So to sort of explain what's going on here, we have this first single quote. So in the code, basically it's creating a SQL statement, a SQL string in there, and it's going to say, select, surname and last name from users where ID equals 1. So that's the kind of thing that's going on in the background there. But what I'm doing is I'm saying where it says where ID equals 1, I'm saying, hang on a second, let's break out of that. All right, and now let's add some stuff. And to do that, I'm going to use the union all SQL commands. And then I'm going to add my own select statements here. So I'm basically saying, all right, stop processing at the end of that SQL command, and now add what I want in there. And as long as I know how many fields are in that database, I can trick it into giving me whatever information I want. So a good first example here is if the web app is really vulnerable, which this one is, we can paste this in, which can then load Etsy password into this first name field. Okay, and we're going to do a few more here because really we don't see a lot of people going for file system stuff. Usually that's protected, but what people are looking for is more information about the database. So there, I now know that you guys all know now that I'm running Ubuntu 12. I have MySQL version 5.5.29. So if you want to go search a CVE and see if there's anything with that, you might have some leverage there. And now we're going to look and see, well, who's running the database? Who's this application running as? And here we see it's root at localhost and root at localhost. And if somebody comes and sees this information, it's pretty much game over. Anything in the database is now, I know how to ask for it because I know I'm running as root. And once I have the root at the database, I can start jumping out of this application and into other applications. So we have seen several instances where folks have web servers running as root or SA. Something happens to this public thing, and all the data that's behind the cosign side of it, goes bye-bye, and that's not good. So, and to last example here, to give you an idea of what I can start asking out of the database is, let me get the passwords out of the database. So these are SQL hashed. I forget what exactly that algorithm is that they use, but when we've seen this stuff leaving, we've been able to grab those strings, and a lot of times you just feed that string to Google, and it'll take you somewhere that are just rainbow tables of this SQL hash equals this password. So we've been able to see, what people's passwords are, and I uploaded that to Google. I asked Google about that and didn't know about it, but there are places where I could basically say, here's my hash, upload it, a few days, week later, whatever, it might be cracked. There are people out there that are just cracking that kind of stuff. So that's the kind of stuff we're trying to stop. And again, if we come over here, I have an application that's protected. It's functioning as I expect it to. It's doing exactly what I want it to. But when I take that same command with pretty much it's the exact same code, it's the exact same setup. All I did was CP DVWA to CP to DVWA-protected. There's really no difference here. And I hit submit. ModSecurity gets in the middle of that and basically says, forbidden. You cannot do that. And that is configurable. So if you don't like this forbidden, you can tell ModSecurity, hey, I want your default action to be our standard error page. And then people aren't really realizing that, oh, I recognize that. That's ModSecurity. But also, I'm giving information away here as far as Apache 2.2, Ubuntu, this kind of stuff. You want to leak as little of that as possible. So that in a nutshell is kind of what we're looking at. It's not very exciting, but that's the kind of stuff we're seeing on the network. So you want to get me back again, please? Okay. So basically, when I set up the web server, this is what we were doing. So I think that's. Again, this is an Ubuntu server. Red Hat's not going to be too much different, but it's broken out in the file system so that there is an etc ModSecurity directory with a comp file, and this is your basic high-level configs where you're setting certain memory limits. You're telling it whether it's on or off or in detect only mode, and you can run this in detection only mode so that you're basically catching all the logs, but it's not sending out that 403 forbidden. Your website's still functioning as it would, but ModSecurity is sending a bunch of stuff to logs saying, this is what I would have done, which is very handy for troubleshooting. And if you do decide to use this, to stand this up, I'd highly recommend spending time in that detect-only mode and getting a feel for where things are gonna slip up. So the rule set that comes from OWASP is in user share ModSecurity CRS, which is the core rule set. So I'm going to say CRS a lot. That's the core rule set that OWASP maintains, and those are broken out, different files. So you can it's not one big, huge, long file. You can say, all right, this is my SQL injection stuff. This is the cross-site scripting stuff. These are the protocol anomalies, so on and so forth. And then the Apache config file. And that's where you basically can start to look at various scopes at the directory level or your entire server or a location or even a single page. And that's the example we kind of just saw there. So, so when we talk about what it takes to manage ModSecurity, there's two major places you're going to be looking at stuff, and one is those rule sets, and the other are the logs. And I didn't put that up there, but I should have. But var, in this case, it's varlog Apache 2. On Red Hat, it'd probably be varlog HTTP. Has the ModSecurity audit logs in it. So I mentioned before, ModSecurity has its own language. It's not incredibly complex. If you guys know regular expressions, it'll kind of make sense. The default rule set from OWASP is very broad. It is very comprehensive as far as the types of attacks that it attempts to detect and stop. That being said, if you deploy this, you're going to have to tweak rules. You're going to have to either modify the actions that the rules take, or you're going to have to turn those rules off because they will break parts of your application. You'd have to be running something very plain and very vanilla for ModSecurity to not kind of get in your way at first. And the logs, they're really verbose. They are not like little one-line syslog. They are actually looking at a deep dive into the HTTP transaction, and we're going to take a look at that here in a second. they contain really a lot of information for troubleshooting. So if you are having an issue where a page is updated and suddenly it's getting a 403 forbidden or whatever your path is, the logs are very helpful for troubleshooting. Again, because the size of the logs, and if you're on a busy server, we can encounter performance issues, and not just at the logging, not just on the back end side, but ModSecurity introduces a performance hit on the front end. So when a request comes in, it has to run through ModSecurity. So there are performance issues to consider with that, and we'll focus on. So before we get too much into the rules of the logs, ModSecurity basically looks at an HTTP transaction as 5 distinct phases, is what they call them. And that is the, I'll cheat, request headers, the request body, the response headers, the response body, and the logging. And so basically this is what the client side is asking for, and this is what you're sending back. And it looks at all of that. And you can, much like firewall rules that kind of chain down, you have these 5 places where you can specify various actions and various ways to catch what's going on and do what you need to with it. And the reason I mention this is because when we get into some of the logs and some of the rules, a lot of the stuff we're looking at is in phase 2. So we're going to see that phase 2 in there, and just so you understand, that just means we're looking at the request body. So basic rule looks like this is the directive that ModSecurity. So this is part of the language. It says sec rule. Give me some variables, and these variables are vast. It can be anything from the server args that you're used to seeing in Apache. It can be things about the cookie, file name, file size, all sorts of stuff you can capture with these variables. Operators can be things like regular expression. It can be strings. They have things to do numeric operations, equals, greater than. You can do GeoIP lookups. So if you don't want people from a certain country, or you want to flag it when people from a certain, you can do that here. And then at the end of the rule, you give it some actions to do. So insanely, you'll never see a rule this simple in ModSecurity, but for the sake of us being on this screen, basically this says, sec rule args, which is, any of the arguments in the request header or request body, if they match this script, so you're basically looking for like cross-site scripting or people to put code in your request that doesn't belong there. Let's log that, deny it, and send it a status 404. So that's as insanely generic as we can make a rule to fit on a PowerPoint slide. And before we get into looking at rules, I do want to talk a little bit about some theoretical stuff as far as whitelisting versus blacklisting. When you're thinking of whitelisting something, you're really looking to address a vulnerability or an issue that you know about, that is specific to your environment, to your code, to your application. And if we look at that, so if we think back to that rule that we just showed on the last slide, this will be like sec rule args ID. So if let me step backwards. So if we think back to the DVWA app, where I was putting a 1 or a 2 or whatever into that input field, clicking submit, that's really going to be a single number all the time in there. That's just knowing the app. It's going to be 0 through 9. I click submit. So I know that the only thing I want coming out of that application is a single number. So what I can do is I can whitelist this and say sec rule, if the args in the request or the ID, it needs to start with a single number and end with nothing else. And then you can put your pass, allow, whatever in there, and it can keep processing rules if you want it to. But to give you the idea, this is what the whitelist would look like for that DVWA, for that specific application, that specific form that we were just looking at. On the other hand, blacklisting, it's really aimed at exploits. And while we understand a lot of the exploits that are out there, we're always playing catch up with that. So, in this case, it'd be sec rule, args. If it's the ID, we got to throw the kitchen sink in there to capture, whether I'm looking for users or whether I'm looking for database information or if I'm trying to escape out into the file system and all sorts of. So I'd really have to have a understanding of the attacks as opposed to my code and my application. And that being said, the core rule set is largely a blacklisting approach. But these are folks that are doing web app security all the time, all day, and so it is a very good blacklist. If you find yourself needing to customize rules or write your own rules, the best way to do it would be that whitelist approach, if at all possible. And this doesn't just apply to mod security. If you guys are writing code for web servers and you can validate input, very strictly like this, as opposed to trying to figure out every bad thing that might come in, it's a really helpful, theoretical way of looking at not just your mod security install, but your code in general. All right, so let's go out and actually look at a rule. Jen, can you get me out there again, please? So we did that simple rule, and we're going to actually look at what a rule really looks like. And so there is a whole rule set here for the SQL injection. And there we're getting into, so here again, this is sec rule is our directive, our mod security language. We're looking at a whole string of variables here, and it will do XML parsing. It just didn't mention that, but if you're heavy into XML, mod security can parse XML for you. So this one's looking at your request cookies, request cookie names, request file name, the arg names, the args, and anything in XML. And then it's coming in and looking at this big giant regular expression. So who here loves regular expressions? You want to put that poll out there? Yeah, we got one. All right. So yeah, I'm putting a poll out there on Adobe to see how people like regular expressions, because I know sometimes that can drive folks crazy. And that is one of the skills that if you find yourself using this a lot, you're going to get good at really fast, is what exactly does that regular expression do? And one of the tools that we have, sorry, I'm kind of going tangential here. Have you ever seen regexer, anyone? So this is a great tool where you put your regex up here, and then you start putting text down here, and you can sort of start figuring out what's getting caught on my regex. And so I have that up. We're gonna look at that here in a minute too. So anyhow, there's our regular expression, and if we look up here, the rule kind of tells you what we're looking for. We're looking for specifically like these 1 equal 1, 1 equal, they're basically looking for probing type of stuff where this is specific to blind SQL injection, where they're looking to do a test against your application to see if you can get it to say true one time and false another. And if you can start to figure out that difference, and I can start asking it whether something is true versus false, I can start saying things like, can I have the first letter of your database? And you can start saying, well, is the first letter of the database greater than or less than this ASCII character representation of it? And you can really start to grab data, even though you're not doing that nasty stuff that I sort of showed you there, where it's dumping it out to the application. You can figure that out based on response sizes and how the server behaves. So this is looking for a lot of that that kind of stuff. It's also looking for like null character endings. Again, we mentioned this is going to apply to phase 2, and here we get into a whole bunch of stuff. And this is why it's great that that OWASP maintains this stuff. They're keeping track of revisions. A really critical field is the ID. This shows up in the log, so it's really awesome to be able to triangulate and say, oh, something scored in the log, but it's saying this big long weird rule number. I better go back and take a look at that rule and see if that's something I really need on, or see if it's something that's tweaking, or if it's an issue with my code. And then these are the T's. This is basically saying, all right, do a transform for me. And I'm not exactly sure why every rule starts with a transform of none, but then a lot of times we're looking at doing a URL decode to uni so that the regular expressions are a little more regular. And then you get our action that we're going to do here is block. So that's going to stop. If it matches that regular expression, it's just going to drop the request or send it off to the 403 actually. And it also has a message that goes out. So again, this goes out to the log file, and it is somewhat descriptive so that you kind of know the general reason why that was stopped. So this is comment sequence detection. We're also telling it to capture stuff, log data, and then we have all these tags here that it's a web attack, it's SQL injection. WASI, I wrote that down. Web Application Security Consortium has that, has this specific catch is listed as 19. OWASP also keeps track of this stuff. SQL injection is their #1 on their top 10. Are you guys aware of the OWASP top 10? Anyone? Yeah, so let me take a little detour here. So OWASP maintains a top 10. So that's the A1. That's what I was talking about. But well, that's not what I want. So they maintain a top 10 problems with web applications, and there we go. So, injections at the top, cross-site scripting's next, broken authentication. I'm not going to go through this, but you guys should definitely become familiar with this, because not only does it say these are the problems, but as I was at there are tutorials on how to mitigate these various issues. So anyway, back to this. So that's the OWASP part. And then you can start doing a lot of things, like here, the set variable, and you can do an anomaly score, and it's plus whatever. You can start to if you don't necessarily want to block traffic, you can start to score it. And as it hits on more and more rules, you can sort of get to a point that says, if this is over a certain score, now let's take action on it. So maybe it's just a probe coming through, but then they realize something's going on and they go to the next level, and you can see what's going on with that, and block things based on scoring as it falls down through that rule set. Any questions on rules? I know this is a very brief crash course. The language, I mean, this book is excellent. The whole back half of it is a lot of details as far as the rule writing language and what's going on there. Any questions on Connect? All right, we'll keep going then. You want to get me back, please? It's the ModSecurity Handbook. Well, we'll go over that at the end. Ivan Ristic. So he wrote ModSecurity, it's a great book. So that's a brief look at the ModSecurity rule set. So now we're going to talk about the logs. And as I said before, they can be incredibly verbose. And there are ways that you can start to minimize that logging footprint. This is usually the default, the sec audit engine, relevant only. That means ModSecurity is going to process every single request. It's not going to take action on a lot of them, but you really want it logging the ones that it's taking an action on. So if it's blocking, if it's doing something, that's when it's going to write stuff to logs. You can also start to change the amount of stuff that's logged. So ModSecurity, the logs, like I said, are not standard syslogs. They actually come in several different parts. It's A through K, and then Z is your ending boundary. So A and Z are required. You can't, ModSecurity will barf if you don't have an A and Z in here. But then it's basically going through, this is your request header, this is your truncated request body. So basically it's saying, give me the request body with everything but a file. D's reserved. I think E and F are the response headers. So if you know that your response is going to be the same all the time when you do something, you don't necessarily have to do that. If you're testing something and you want to see how your application responds, this E and F are great ones to have in there. H, you'll want, that's all the detail that says, that ModSecurity says, hey, this is the rule I triggered on, this is the information that you're going to want to know if you're troubleshooting, this is why I did this, that kind of stuff. And Z is our boundary. Ending boundary. So we briefly mentioned at the start that there can be performance issues here. By default, ModSecurity does a monolithic serial log to file. So what that means is that when there's an HTTP request, Apache is basically not going to be able to process another HTTP request until that log is written to file, until ModSecurity is done with that transaction. And so if you've got a really busy web server and you're suddenly bound by how fast you can write logs to disk, that can become a problem. The places we've run it, we haven't really run into that issue, but if you do, you can start to pick up on what's called concurrent logging. And so what they'll do is you'll be able to run more transactions, more HTTP requests, and it'll write out single files to the file system with each log in a single file. And it has directory structures with timestamps and stuff like that. But now we're getting into file system and disk issues where you have tons of tiny files. And so that can start to, if you have inode limits, if you have certain file number limits on there, that can cause problems. So what ModSecurity has done is come up with a remote logging system similar to syslog, what you guys are used to if you have a central syslog server. Basically, ModSecurity has its own logging daemon called mlogc. And so when you turn on the remote logging on the server, it basically goes into this concurrent mode, writes it to disk, gets that off over the network to the central logging server, and then gets rid of the stuff in your temporary scratch space or wherever you tell ModSecurity to write those temporary logs. So as I said before, you will have to tweak ModSecurity if you put this out in front of your web apps. There will be false positives. There'll be times where it's really difficult to figure out why something happened, and that's where, again, that regexer tool is excellent. You basically copy out that regular expression out of ModSecurity, put it in there, and then you can go to your logs, grab the headers and the request body, and it'll light up and say, this is what I was flagging on. And you'll be able to really visualize and see what exactly ModSecurity was trying to do. I mentioned the logs record the rule ID. This is a great way to triangulate, to say, when I'm looking at the logs, I have all this information, I need to figure out what rule that is. The ID or the message are the great ways to do it. And then once you sort of figure this all out, you can start to decide how you want to deal with those false positives. And ModSecurity has directives in the language where you can say, at the file, at the page level, at the location level, at the directory level, at the server level, anywhere in scope, to basically say sec rule removed by either ID or message. So, within the scope that you set it, anytime that ID comes up, ModSecurity is just going to skip it. So you actually have some flexibility there. You don't have to comment the rule out and turn it off for the entire server. You can just turn it off for a certain page, and that way you sort of limit your exposure. So you can skip the rule this way. You can also do a sec rule update action by ID. So if the action is to block, which most of the rules are to block, you can sort of change the action that takes place. You can say, all right, let's just score this as a +1, and then keep feeding it, pass it on down the rest of the rule length, or the rest of the rules, if you so desire. And Jen, if you want to get me over, we're actually going to sort of step through a quick example of how that works. Because when I installed DVWA and then I turned on ModSecurity, nothing worked. So I couldn't even get to this. I couldn't even get to this page. It would just immediately say 403 forbidden, no matter what I did. I didn't even get a chance to put in a 1 or whatever. So it broke the whole app. And so we're going to actually look at some logs and see why that was. No, we're just here. So here's what the audit log looks like, and so we'll go through a basic idea of what we're talking about. So if you see that top line up there, that's the A. That's one of the required ones. That's a basic timestamp, unique identifier, source and destination hosts and ports. And then the section B is our request headers. So you can see these are all the variables you have access to if you want to know about, if you want to block certain user agents. And we know of a lot of them, like Havij and SQL Map. We see those a lot. Shouldn't be coming into your web server. So you could block at a user agent level. Refer, if it's coming from strange places, you can catch it there. All this stuff is available. F, again, is our response header. And you actually get to see, so this is the code version of that 403 forbidden page that we saw. So we're actually looking at, the response header, the response code that was sent. And here is the big long message from ModSecurity. So you can see we're ending with the Z. So this H, this is all your debugging information that comes through here. So it tells you, hey, we denied with a access code of 403. We're actually going to find the log that we want to go into this. And 96017 was the one I was having issues with. Yeah. So when I first started this up, none of the WA stuff would work, and I kept getting this 96017 rule was being hit, and I'd get the 403, and it even tells you, hey, look, I matched here, and what that regex basically says is if it's just numeric, start to end if it's numeric. At the request header, host. So if somebody's coming to your server as 128.118.5.5, ModSecurity is going to say, I don't really like that, and it's going to block it. If they're coming at www.science.psu.edu, fine, no problem. And I think the logic behind that rule is that if you want to do a sweep, it's much more efficient to do it by IP than it is to go out and resolve all those IPs. So anyhow, and it tells me where that rule is located. File, user share, ModSecurity, CRS, activated rules, ModSecurity CRS 21, protocol anomalies.conf. And it even tells me if I want to go into that file, we're on line 98. And again, here's this ID. I can, if I just have the ID, I can just do a quick grep of that user share ModSecurity CRS, and it gets me right to the file. And it tells you what the message was from that rule. Host header is a numeric IP address. Severity is critical, protocol violation, and it gives you the rest of that other stuff. And so here it says, what did I do? I intercepted it at phase 2. And if you guys are getting into that performance arena with that, ModSecurity actually keeps track of, here's when I started, here's where I ended. It took 28,000 milliseconds to run this, combined, phase 1, phase 2, nothing on phase 3, phase 4. It took 57 milliseconds to write it out to log. I forget what SR, SW, again, that's what this is for. That's what the book's for. All of this stuff can be referenced. That's basically what we're doing. So anyway, I had this issue, couldn't get it up, kept seeing it as I tailed my log and hit my enter and did all that stuff. I kept seeing this 960017. So I said, all right, let's figure out what to do here. And so I went out of here. Oops. I looked at my log. We were already in the log. So I used that information, and then I can grep 96017 asterisk. And even though it told me, again, this is just another way of getting here. So if I less ModSecurity CRS 21 protocol anomalies, I can start to look and see if there's any more information. I can look for that 96017 again, and here I'm right at the rules. It tells me that if the host header contains all digits and possible port, this is not an HTTP RFC violation, but it is indicative of automated client access. So, that's a place where they've decided to go against RFC and say, all right, the stopping the attack is more important than being RFC compliant. So this is stuff you gotta have to be aware of. And it says this rule triggers if the host header contains all digits and possible port. There's some references to Microsoft. So I can look over this, and this is a pretty simple rule. It's just is it all digits? Well, I'm on a VMware setup. I'm not going to, for you, I like you guys, but I'm not going to go and edit my Etsy host file and put in something there. I'm doing numeric. So fine, let's get rid of that rule. Let's bypass it. And so what I did is Sites enabled. So I went to my directory where I set this stuff up. Again, I have, my vulnerable ones here. It has no sec rule language. It has no mod security stuff in. But for this one that I want protected, I then used that sec rule remove by ID, and then I added the 96017. I also had to add this 950.901. It triggered this PCRE recursion issue, and it actually has to do with just how crappy the code is on the DVWA, and I didn't really feel like editing the code, so I just let that rule slide too. So that's, that's the basics of what I wanted to cover here today. If you want to get me back into the PowerPoint, please, Jen. Oh, yeah. So we just looked at that in the file. And another example, if you wanted to do the update, you could do update actions by ID, and I could do a no log and pass, and that's sort of the same as removing the rule. But again, if it was something that you thought, I don't really want to kill that off, I just want to change what it does, that's possible. So modsecurity.org has all the code. They have it packaged for all the major Linux distributions. OWASP.org is the one I talked about with the top 10. And it has a lot of other information about how you can mitigate those with your coding practices, how you validate input, how you sanitize things that are going to a database. And the application that we were working with there was DVWA, and that's dvwa.co.uk. If you guys are interested in figuring out what offensive security is all about and what you can and can't do, that's a good thing to use. And while we're talking offensive security, I'm going to mention a few tools that we use a lot. So a lot of times we'll see a probe come in, and I can tell that they've got the true-false thing working. So blind SQL injection is working, but they're not necessarily attacking the site yet. They're just cataloging and say, hey, I found a vulnerability. Keep that in my back pocket and see what's going on. There are a few free tools that if you guys are running web servers, if you're developing code, are very useful. The first one is SQL Map. So it's just SQL MAP. Do a Google search for it. It's just a Python script, and you tell it what URL to go to and what variable that you want it to test. And it does a very good job of finding out what's in your databases. It is very effective at doing SQL injection attacks. So if you guys are developing code, highly recommend that. The Burp Suite. Anybody hear of that? Yeah, Burp is what would you call that, John?
Proxy.
It is a proxy. So
basically, it sits in between your browser and the site you're at.
right. So what John just said there, for those out in Adobe land, is it's basically a proxy, and it basically allows you to sit in between the request you're making at your browser and the server you're testing against. And it allows you to edit your different things. So if it's a get, you can turn it into a post. You can start to put cookie things in there if you think that if you can start fuzzing session IDs and stuff like that. Burp allows you to do that. And we use it. It's really handy for troubleshooting. Like when we see something weird and we're like, that shouldn't work, or why is that working? Burp a lot of times allows us to sort of stop. It kind of does what ModSecurity does in slow motion. and I get to sit there and stop it before the request is made and edit whatever I want. I get to take a look at what's coming back in a lot of detail. What other tools that are free? I mean, there's a free Nessus one. I don't know how great that is. Skipfish. Yeah, NetSparker is another one that has a free edition. We see a lot of attacks with a tool called Havij, and it's out of Israel, and it's really sketchy. Like, we don't, we've looked at like downloading it and trying to buy it, but you can't actually really buy it without like, oh, it's just, I don't trust it at all. But people use it like crazy. So if you want to know how your server stands up to Havij, there is a free version. As far as I know, it's been available for years now. I mean, my first encounter with ModSecurity was when I was working in CSE, and we had an issue with a custom homegrown CMS. I was coming in at least once a week, and it was getting crammed full of all these pharmacy ads and stuff like that, and we'd fix that page, and then they'd find the next one that's vulnerable, and that's how I found it, and that had to have been back in like 2006, 2007. The source code's available, so it'll work. I'm pretty sure you have to have Apache 2. I don't think it'll go back if you're using like any of the older pre-2 1.3 or 1. I don't know if they did 1.4, but if you're using the older versions, it's not going to work. It is specific to Apache 2 and later. But it. Yes, so the tools, all the tools I was just talking about, if you're a developer, feel free to use them against your stuff in a very controlled manner. If we do catch you using them across the border, we send you a nice little email and say, hey, what's going on here, and we have seen that where we've given a talk like this and somebody goes home and runs Nessus that night. We're like, was this you by any chance? Because we can kind of triangulate that and see that so anyhow, use them intelligently. Please do not attack our assets or other assets outside, because if you use a Penn State asset to attack something outside, that's a bad situation. Kevin. You mentioned you had to make some list of like things you had to do just. I don't have a oh, so the question was do we, if we know that it has a lot of false positives, do we know what those common false positives are? Do we know that it works well with cosine, our standard Penn State stuff? And not really. There's only a handful of people using it. I know VMhost deploys it in places, so the guys at VMhost are familiar with this tool, and we can find that out. But again, it's really going to be application specific as far as how you tune it and tweak it. Any other questions? Did I read that stopwatch line correct? No, that's so we can go. Can you get me back in there, Jen? So that might have been. I spent a lot of time fiddling with this, but let's take a look at that and actually get into some logs here. So yeah, that is 27. So what if we go down to here after I fiddled around with it, and there we're looking at 4,600 milliseconds. So Yeah, and again, if we look at how much is being logged, if we're looking at if we, if you know your application and say none of these rules apply to what's going on with this directory because I know the code, I can throw all those rules out. And so the way that the configuration works is that it loads. So the way it is this is the Debian way. Is there are activated rules. So if I go into the activated rules, I've just turned on the base rule set basically. Do I need all of these rules? Maybe not. And you can see that if we go back up there, there are other experimental rules. There's Lua integration that I know nothing about. There's some optional rules that go in there, but you can start to trim out what how big that rule set is, and that's what's going to really make a difference with that performance, because most of that, as you could see, is the overhead of doing all the regular expression crunching. And of course, I'm doing it on a virtual machine on a laptop. If we get some memory and some iron behind that, those numbers are obviously going to go down too. So, part of it's just this is a crappy way to do it, but so it is good that thanks for asking that question, because we kind of did talk performance when we were going over this yesterday, and that is a great way to look at that and say, well, if logging is next to nothing, then we got to start thinking about what are all these rules being processed? Do I need all of them? Is this really relevant to my application, to this directory, to this specific thing that I'm trying to accomplish on the web server? Yeah. So the comment was he's looking at 15 requests per second, and if we're talking slowing that down by a lot of milliseconds, then yeah, that gets hairy. So again, when you're thinking about this, you definitely have to take performance into account, and really, it's a very good tool, and it really has its place. If you're in a bind and you can't get the code fixed, we're starting to balance two very heavy business decisions here. Is can I take the performance hit because I need my site online, or do I take the site offline while we fix this whole mess that's happening behind here? So yeah, it's definitely not something I would say, yeah, go install it. Right, that I would never say that. But if you understand your application and you know who your users are and you know who your developers are, and you can get a process hammered out for how you're going to troubleshoot this, do some acceptance testing, and get it out there, it is a fantastic tool to block a lot of the nasty stuff that's coming across, at least that we're seeing across the border. That's a good question. Yeah, so the question was, could we basically do the remote logging setup local to the machine? So basically you set up the remote logging, but the socket that's listening is still on that local machine. And I don't know. I mean, we can look in the book, we can look at a reference. I don't see why not. But if we're getting into a performance issue where you're up there thinking about remote logging, you might not want all that going on your server. So I don't know. I haven't used the remote logger. I just want you guys to be aware, again, we're in that performance area, that there are options, that it's not like, well, this slows my site down, I better give up.